Unit 6, Day 7, the natural base in E. Today you will solve equations and problems involving E or natural logarithms. A natural logarithm is a log with a base of E, and we write it log base E, and we can say that equals a natural log, which is written ln. The second most common base is an E. E is an irrational number that equals 2.7183, and it goes on forever and ever. You can find that number by doing the summation from 0 to infinity of 1 over n factorial, which is described below. A logarithm with a base of E is called a natural log and is abbreviated as ln rather than as log with a base E. E to the x power equals y. So if we rewrite this, we have log with a base E of y is equal to x. We then can replace log with a base E with the natural log of y is equal to x, and then we would be able to type that into our calculators. So this right here is really important to memorize. Log with a base E of x is equivalent to the natural log of x. Since the natural log of x is still a logarithm, all of the properties apply to natural logarithms that we have previously learned. Let's simplify. The natural log of E raised to the 0.15t. If you rewrite the natural log as log with the base E of E, you can see that due to your properties, this would equal 1 whole. So we just have 0.15t. To simplify example 2, we have the natural log of 4 plus the natural log of 6. This, you should think the product property. We have the natural log of 4 times 6, which is 24. We have a 2 out front, and we have a subtraction sign, so we should think of the power property and the quotient property. Move your 2 to your exponent first, so the natural log of x squared minus the natural log of 5. The quotient property, we're going to divide x squared by 5, and we simplify. Example number 4, you notice we have the natural log of e to the 2x plus the natural log of e to the 2x. So we can rewrite that as division, natural log of e to the 2x times e to the x. Power to a power says we multiply, so we have the natural log of e to the 3x. Natural log is the same thing as log with a base e, so this equals 1 whole. These both would cancel out, and we would just be left with 3x. The next slides we're going to solve and round to the nearest hundredth. So if we have the natural log of x is equal to -3, I can rewrite this as log with a base e of x equals -3. I can convert this to exponential form, and I can now type in my calculator e to the -3rd power, and I get x approximately equals 0.05. On example B, I should be thinking the quotient property. So I have the natural log of x over 2 equals 0. I can rewrite that as e to the 0 power equals x over 2, and that's because if I rewrote this as log with a base e, so then e to the 1st power, this equals 1 whole, so I multiply by 2 on both sides. 2 is equal to x. E to the x power equals 5. I can rewrite this in logarithmic form. Log with a base e of 5 is equal to x. I can then change log with a base e to the natural log of 5. When it's in natural log form, I can type it into my calculator, and x is approximately 1.61. In this one, I should be thinking product property power property. So I can raise my power. So I have the natural log of x minus 2 times 2x minus 3 equals the natural log of x squared. My logs cancel out because they're the same on both sides. I distribute, so I get 2x squared minus 3x minus 4x plus 6 equals x squared. Subtract my x squared, combine my like terms, I get x squared minus 7x plus 6 equals 0. I then can factor 6 and 1, negative 1, negative 6, set those equal to 0. When I plug 1 in to my logarithm, 1 minus 2 equals negative 1, which is not allowed. So I know my 1 doesn't work, and my 6 is my solution. Remember, you never want a natural log or a log of 0 or a negative number because it would be undefined. Next, we're going to talk about the compound continuously formula, and that formula is what we call A PERT. A is the total amount, P is the principal, R is the annual interest rate, which you want to make sure this is a decimal. So you need to convert it, and T is the time in years. What is the total amount of an investment of 500? So this is invested originally, so that's our principal amount, at 5.25%, which is our rate, but we want to convert that to a decimal. So our rate is 0.0525 for 40 years. So 40 years is our T, and we can plug this information in. So we're looking for our total amount. When we start with 500, e to the 0.0525 times 40. When we plug this into a calculator, we get our total amount of money to be $4,083.08. The next equation is a natural decay model, and this is the exact same as our compound continuous formula, but this is more generic. So this one is talking about natural decay, which you will refer to in science. N of t is the amount remaining. N sub O is the initial amount. K is the decay constant, and T is the time. So example number 6 says plutonium-239 has a half-life of 24,110 years. How long does it take for 1 gram sample of plutonium-239 to decay to 0.1 grams? So this half-life right here is really important. The first thing we need to find is our decay constant. So we know that we are talking about 1 gram. So they are asking if we have 1 gram as our initial amount, when is it going to be half that amount, which would be 0.5. So 0.5 would be our N of t. N sub O would be 1. We then have our E. We don't know our decay constant, so we have to solve for K. And our T is going to be our years, which they told us was 24,110. So then we need to solve for our decay constant. So we can add the natural log to both sides. And when we have the natural log of e, that's the same as saying log with a base of e. So I'm going to leave it natural log on the left because we can easily type that into our calculator. But if I rewrote this as log with a base e, you can see that these would cancel out and we'd be left with 24,110 K. So we divide by 24,110 to get K by itself, which is our decay constant. And when you type that into a calculator, you get negative 2.87 times 10 to the negative fifth in scientific notation. So you could write it like this. Or I would also accept that K is equal to the natural log of 0.5 divided by 24,110. You could then find out how long it takes for it to get to 0.1 grams by plugging in this new K into your formula and solving for T. The next example says determine how long it will take for 650 milligrams of a sample of chromium-51, which has a half-life of about 28 days, to decay to 200 milligrams. So again, our original amount is 650, and we want to know half-life. So when is it going 325, because we're solving for our constant, e to the, our constant we don't know, but our time is 28 days. So then we can divide by 650. So 325 divided by 650 gives us 0.5. E to the K 28. If we take the natural log of both sides, natural log of 0.5 is equal to our natural log of E cancels out, 28K. Divide by our 28 and our decay constant. If you take the natural log of 0.5 divided by 28 is negative 0.0247. After you find your decay constant, you can find out the amount of years for it to decay to a certain amount of milligrams, like 200, by plugging it back in. You now can complete your worksheet.